Okay, since photography is obviously about light, anybody that's interested in photography will find this of interest as well. Let's first start off with some fundamental principles of light. Light has 66% of the speed going through glass. However, light is not a speed, it's a rate of induction. Through vacuum, light is 186,000 miles per second. Of course, it's not a speed, it's a rate of induction, and it's about 124,000 miles per second going through glass. Now, the variation on that, which would be index of refraction, has to do with the composition of the glass. This is like the reason why radioactive stuff is actually added, like thorium doping, to older lenses. It actually changes the refractive index, but when I say refractive index, it doesn't mean anything. It actually pertains to how it actually bends the light itself. So, why would it be the case that blue light is refracted through a prism much more than red light? Here we have the actual angle of deflection or angle of refraction of red light, green light, and blue light. Why would that be the case? Let's take a look at the spatial footprint of red light, for example. Okay. Now, unlike conventional thinking, a human being thinks that a larger box can contain more stuff. So here we have a larger spatial footprint of red in frequency of light. So why is this actually deflected less through red light than blue frequency light? Because blue frequency light actually has, if I can draw this properly, quickly, has a much smaller spatial footprint. Here we have light, as I've told you before, and as I mentioned in my book, has a transverse E and M, longitudinal pulse perturbation. These pulse perturbations, which are actually rarefactions and compressions, is what modern relativity and quantum mechanics is actually called the photon. Of course, there's no such thing as a light particle. This is an absurd concept, a purely arbitrary concept, an abstraction which is not the output of any experiment ever done. So why would something that's much smaller, and this is the case if you could take a look at the equation in the upper right hand, you have E equals nu V, which should be energy equals Planck's constant times the frequency of light. Let's take a look at red in spectrum of light. We're not going to specify their frequency, but on average, it's 1.77 electrovolts. And blue in frequency, or towards ultraviolet, we have basically 3 electrovolts. So almost twice as much. Glass is a capacitor as well as a resistor. Now, people think that glass is an insulator. There's no such thing as a perfect insulator. Glass is also a capacitor. This is the same reason back in the day when power would go out along the along the electrical lines. When it would go back on, there would be a surge of electricity. The old pure glass insulators, which are actually on the electrical lines, they would actually explode, and the linesmen would have a hissy fit, and they'd go out there and they would pull off all these exploded. It's the same reason why the non-microwave safe glass would explode in the microwave back in the day. They still do sometimes. People always thought that was due to overheating of the glass bowl. It actually shattered. No, it's actually the fact that the glass reached its capacitance. This is also the reason why prime lenses render light better on average. There are a lot of, especially the modern lenses, modern prime lenses, which have way too much damn glass in it, render really crappy images. People say, well, a prime lens is better than a zoom lens. Well, that's not saying a damn thing. Well, why the hell is a prime lens better than a zoom lens? Typically was the case, except for now. Prime lenses had a lot less glass in them than zoom lenses. Also, the optical construction got better. The coatings don't really account for anywhere near. Some of the best lenses that I have, some of the best lenses in the world, are old lenses with no AR coating at all. None. While they do have issues with flare, they actually render the images really beautifully. So all these idiots on YouTube that actually talk about coatings being the major improvement in lenses, they are talking out of their ass. Not only are they clueless, but they're also stupid. So, smaller space, the higher the capacitance. Law of conservation of energy, this is where you would stump any scientist, is just ask them, how is it that light speeds back up again after it leaves a prism? This doesn't make any sense to conventional thinking. How is that the case? We have a glass prism. You pass some white light through it. Doesn't matter what light we actually pass through it. Okay, it gets deflected. Okay, right through this section right here, it has 66%. In other words, it's actually decreased by 34%. 34% decrease. With my handwriting, it really sucks. 34% decrease right here. Okay, here we have 100%. And here we have 100%, which is 186,000 miles per second. I.e., quote-unquote, the speed of light. Without breaking the law of conservation of energy, anytime you ask a scientist, well, how does light speed back up again? You will get the most this is what they'll say. They'll say, well, it just speeds back up again. Or they'll actually say, well, this frequency of light had a certain speed before it enters, so obviously it has to have the same after it. That's not explaining everything. Everything in the world is capacitance, resistance, magnetic permeability, and dielectric permittivity. Glass actually has, glass is not only an insulator, it's also a capacitor. Light is not a speed, it's a rate of induction. A wave is not a thing. A wave is what something does. There's no such thing as light. No one has ever seen light because we've never defined light in itself by itself. We cannot differentiate out light from what light does, i.e. waving. But waving is not a thing in and of itself. Neither is a shadow. A shadow is a privation of light. The reification of a shadow, for example, obviously has no basis in subjectivity. It's not a principality. We have a person. Maybe let my stick figures right here. Here we have the shadow on the ground. If we remove the person, what is this? This is absolutely nothing. A shadow is not a thing. A shadow is a privation of light. Light has no subjectivity. If we remove out what we define light to do, i.e. its attribute, if we take light and what we think we know what light is, the big L, and we're going to say over here, illumination. Okay? If we remove illumination, we should be able to define light in itself by itself, but nobody has ever done that, ever. Light does not exist. There's no such thing as a light particle. And people talk about, well, the frequency of light. Okay, let's talk about the frequency of light. Okay, here we have, I don't know how many megahertz of blue light. There's the frequency. There's the EM, and of course we have the longitudinal pulse perturbation, and this is where the idea of the photon came from. Anytime you rarefy or compress something, you'll end up with bumps, kind of like speed bumps. You know, when you rarefy and compress something, this would be rarefaction, and then compression. This would be rarefaction, and here would be compression. Let's take a look at this over here. I love my great handwriting. Here would be compressions, and here would be rarefactions. This is where the concept of the photon came from. E, energy, equals frequency. Energy equals Planck's constant times the frequency of light. This is Planck's constant right here. Blue in spectrum light. Why is it deflected more through a prism? Smaller in space, the higher the capacitance. So why is blue in spectrum light? We know, for example, that what would be the wavelength? Like 420 nanometers. Let's actually draw it out here. With my crappy handwriting. Okay, let's just say this is 420 nanometers. It should actually be more ultraviolet light. And let's draw out 700 nanometers of red light. Okay. Look at this huge spatial footprint, 720 nanometers. Okay. We have average 1.77 or 1.75 EV volts. And in blue light, we basically, if you can take the difference between blue light and ultraviolet, 3 EV volts. How do you like that 3? Well, that's some really crappy looking 3 right there. Smaller spatial footprint. Boy, I didn't actually do that very well on a frequency here, did I? It's hard to draw these little waves. There we go. There we go. Smaller space, the higher the capacitance. Space, by definition, by the way, and this is something you never learned in college, and it's so simple because Mother Nature is really simple. Space is not a thing. Space is the posterior attribute of the loss of inertia. Space and magnetism are one and the exact same thing. So, and magnetism is the loss of inertia. This is always equal to force and motion. So let's take the inverse of that. What would be the inverse of force and motion? Inertia and acceleration, right? Here we'd have to draw something infinitesimally small. Basically, I'd have to draw a counter space, and I can't draw a counter space. So I could say, well, a counter space would be a point, but even a point would be incorrect. I'm still going to stick a point there. What would the opposite of space and magnetism? It would be counter space, and it would be inertia, or the ether, or energy. People think of energy as a release of energy. Well, I hit the gas pedal, and the car goes forward. No, that's the release of energy. That's the expenditure. That's the loss of energy. But you can only define energy, human beings can, by the release of energy. When we talk about energy, we think of the release of energy, but the release of energy is not energy. It is the opposite of energy. It is space, it is force, it is motion, it is magnetism. I know you heard back in school, and of course they never told you why. They said, well, every atom is 99.9999999% empty. Well, it's not. That's magnetodielectricity. Magnetodielectricity. I'm not going to spell it out. My handwriting sucks on this whiteboard, doesn't it? And that is mostly magnetism. Every atom is obviously a dynamo. It's a dielectric condensate. So what do we know about light? Light doesn't exist. We only define light by what it does. Nobody's ever defined light in itself, of itself, by itself, as a thing. Light is not a thing. The big L. We only know this right over here, illumination. And we only know illumination as a field perturbation. Light is a coaxial circuit, transverse, electrical, magnetic, either linear or circular polarization. Longitudinal pulse perturbation. Here I'm going to try to get it right this time in my drawing, okay? Here's rarefactions, here's compressions. Look closely. Actually, I should make those a little further spaced apart. Here we go. And compressions, rarefactions. So here we'd have the compressions, the speed bumps. In the longitudinal, this is the longitudinal aspect of the coaxial nature of light, okay, right here. Transverse, electrical, magnetic. The only reason light has a quote-unquote speed is because it has a spatial footprint. In really simplex terms, this is the spatial footprint of all light regardless of frequency. But light is not deflected more towards the blue end of the frequency due to the smaller spatial footprint going through glass, but rather the capacitance, or the actual energy, higher energy in blue end spectrum light times the Planck's constant. Energy equals Planck's constant times the frequency of light. Blue end light, once you go towards the blue end spectrum of light, you're starting to travel towards gamma radiation. Towards the red end, you're going towards infrared, less powerful. Well, that doesn't make any sense. You would think, I'll get to that in a second. Here you can actually see the arbitrary concept of the photon right here. These compressions in the longitudinal pulse perturbation, and light itself is nothing other than a field modality. It is a complex field modality. A coaxial circuit of transverse electrical, magnetic, and longitudinal rarefactions and compressions, which actually define light. Now here's the counterintuitive part. Since human beings don't understand that electrical theory is inverse to common, conventional thought, here we have red light with its huge spatial footprint, and here we have blue end frequency. Light's actually a lot smaller than this. Tiny. So when we pass light through a prism, this would be right here, blue end light. This is the deflection. Hold on a second. Now let's draw red end light. This would be red light right here. Okay, here's red, and here of course is blue. Why is blue light deflected a lot more than red? Blue has a much smaller spatial footprint. You would think that something that's really small would get through a glass prism a lot easier with less deflection than red light, which has a huge spatial footprint. But just the inverse happens. And why is that? Because the smaller the space, the higher the capacitance. Energy equals nu V. Energy equals Planck's constant times the frequency. Now we know why blue light gets deflected more. Now we know why zoom lenses and really complex prime lenses have really if you actually compare a simplex prime lens against a really, really complex zoom, or complex prime lens with a crap load of glass, you notice that the blues are washed out. You can always notice that. If someone, of course, people change the saturation in post-production and editing, so you never really know, because every image has been screwed with in Lightroom or Photoshop, so you can't tell. But straight out of the camera, you can tell. Especially if you take a picture of something blue off in the distance. Through the haze, it's noticeable. But you could fix that in Lightroom, but that's not the point. Because all of that light actually contributes to microcontrast. Smaller space and higher capacitance. Here's the question you should always ask so how do you out breaking the law of conservation of energy? How is it that light speeds up after it's, because once it hits right here in the glass, it's only 66% quote unquote the speed of light. Like I said, light is not a speed, it's a rate of induction. There's nothing traveling. This is what people also don't get. There's nothing traveling when it comes to light. Nothing emits light. Here we got a pond. Okay, and in the pond we got a guy with his head and his arms in the pond, and he's flapping his arms. Okay, stays in the middle of the pond. What the hell happens? It's a release of energy, force and motion. What happens? The water would be synonymous to the ether. A field perturbation. How the hell is the person actually causing waves to lap on the shore over here, anywhere actually? How? The person's right here, remains fixed. Nothing emits light. Light is not a thing. Light doesn't travel. Same thing with waves in the ocean. And we're not talking near the shoreline because we actually have to account for the sloping seafloor at the shoreline when it comes to an ocean. But actually out in the ocean, waves don't travel. You can actually take a styrofoam cup. You'll actually see it'll stay in the same spot. This wave causes a wave over here, up and down, like pistons. They don't travel this way. They don't. Light does not travel. It's a field perturbation. The person in the middle of the pond doesn't travel. Where the hell is the person in the middle of the pond going? Are they emitting anything? No, they're flapping their arms in the middle of the pond, right? Really simplex analogy. Nothing emits light. Light is a field perturbation. Nobody can deny the ether. You will not get a single scientist, you can always confound them, because they always say one of two things. Like when you have light go through a prism, here we go, here's the rate of travel, here's the angle of deflection, here we have 66% the speed of light, or light slows down by 34% roughly, depending on the nature of the glass and the compounds added. So this is 66% of the speed of light, here's 100%. Without breaking the law of conservation of energy, okay. How does light speed back up again after it leaves the glass? Nothing is entering the glass, nor is anything leaving the glass. The easiest way to actually prove the ether is have a debate with an asshole scientist, a relativist, a quantum theorist, and these people are one thing and one thing only. I'm going to tell you what all of them are. They are, well, there we go. Atomists, i.e. materialists. This is what they all, here we go. What else are they? They're this. This is the cult of bumping particles, as I love to call them, the CBP, cult of bumping particles. Okay, without breaking the law of conservation of energy, states the total energy of an isolated system remains constant. It is said to be conserved over time. What's conserved? There's no gasoline inside light. They're like, well, the light tells itself, hey, we've left the glass. Let's actually stick on the gas pedal and speed back up to 100% of the speed of light. Light's not a speed. Light is not a thing either. We know light's not a speed, it's a rate of propagation. Light is also not a thing, it's a field perturbation. Mother Nature is really, really, really simple. The only way you could actually explain light having the exact same rate of propagation, or what the common idiot would call speed after it leaves glass, is one word only. Because Mother Nature is really simple. Okay? One word only. Right here. Here we go. So simple. Just like the person in the middle of the pond flapping their arms. Ether! You can never explain, and I never said light was instantaneous. I don't know why people keep saying that. I refer to instantaneous action at a distance, but not in relationship to light. The reason why light is not instantaneous is because of this. This is really simple too, because I told you Mother Nature is really simple. This is light right here. It's coaxial circuit. Here's the longitudinal rarefactions and compressions. Here's the transverse electrical magnetic. The reason why light is not instantaneous and it's really simple is because of this. You see this spatial footprint right here? Anything that has a spatial footprint, whether it's linear polarization or circular polarization, i.e. light, cannot be instantaneous, because anything that has a spatial parameter has a phase. And that phase is called EMR, electromagnetic retardation, which means it cannot be an instantaneous propagation. However, scalar waves can be. However, scalar waves is a bullshit term, because scalar waves are not waves at all. They're completely longitudinal. There are no waves in scalar waves, okay? These are waves right here, okay? You see? Those are waves. There are no waves in scalar waves. What there are in scalar waves, however, are these. Hold on a second. Here we go. Rarefactions and compressions. Here are the compressions, and here are the rarefactions. Okay? Now let's wait. Let me tell you once again. This is where the concept, an arbitrary concept, pulled out of the asses of mental midgets, knuckle-dragging, pseudo-intellectual morons, because human beings are not that smart. This is where the concept, totally arbitrary, never been the output of any experiment ever done, photons came from. There's no such thing as a light particle. Bullshit! It's an absurdity. It's nonsense. Poppycock. Crapola. Insanity. Stupidity. I've been taking pictures all day. I'm going to take the lens off my camera and shake out all these photons. My camera's full of what the hell? There's no such thing as a photon. Anyway, I could talk about that for hours. So, here we go. If you like these videos, you can always make a small donation. Or what you could do is you could tell me to jump off a cliff. Yay, whatever. Cliff, there we go. My handwriting. My hand. I've been typing for so long. I put some hair up here, but I don't have any hair. I got freckles, though. Don't do anything. As long as you learn something, that is all I actually do care about. Okay? Lux e veritas. Bye. Oh, wait a minute. Wait. For all those people out there that think I'm from another planet, I gotta finish up the video this way. Okay? Hold on a second. There we go. There we go. All those people that think I'm in the Illuminati. I never said I wasn't.